Hello grade 12s, welcome to this lesson where we will be talking about the interpretation of a cubic graph. I hope that you will be working on your side as well, actively involved, to see if you can work out, the solution of the question by yourself. And obviously, as you proceed watching this video, you will get the detailed solution of the question itself. So let's take a look at the question. All right, so what did we see? We saw a cubic graph that has a tangent, and this tangent happens to intersect this cubic graph at two different points. So it has 2 points of intersection, and for one of the points we're asked to determine the coordinates of that point called point A. Okay, point B is also a point of intersection, that is your other point of intersection. However, we are given partial coordinates of point B. In other words, we're just given the x coordinate, and we will definitely need to solve for the y coordinate. In this case, at the moment, is given as P. All right, so what do we know about the relationship between the tangent and the gradient of the graph? We understand that the gradient of the tangent is equal to the first derivative of the function g in this case, and it is defined by this equation, the g of x, and f of x is defined by 4x plus t. Okay, because A is a point of intersection, we know that is happening. Okay, you have your x coordinates equal, your y coordinates being equal. In other words, the expressions are equal to each other at points of intersection. Okay, so let's go for it. Let's start. We know that the gradient of the tangent is equal to the derivative of g at the point of contact. In this case, B is a point of contact, but what is the x coordinate? It's 3. Okay, so in other words, we're going to take this expression for g and then derive it. What is the gradient of f? By just looking at the equation. It's a linear function, it's a straight line graph, so it's 4. So 4 is equal to what? 3x squared, but your x there is 3 minus 4x. So it's going to be 4 times 3 plus k here. All right, and the x will fall away. Derivative of 12 is 0. It's a constant function. So this is what we have, and clearly we see that this equation will allow us to solve for k, and then we can bring it in there to have a full equation representing what? Our cubic function g. Let's go for it. We have 4 equal to 3 squared, 9 times 3 is 27. 27 minus 12, this gives us 15 plus k, and therefore k is equal to negative 11. All right, so we can come in there and then fix for k and write it like that: x cubed minus 2x squared minus 11x plus 12 is equal to 4x plus t. So we will also need to find the value of t, and then what does t represent? It represents the, yes, correct, I hear y-intercept of this tangent line. Right, we are making progress. That is good. What can we do now with the point of contact that the tangent makes with the cubic graph? We have that the point B is a common point, and therefore we can substitute 3 in the expression of g to get the corresponding y value, which will represent what? The value of P for us. Yes? Good. So let's do that. We know that P will be obtained by substituting 3 in the expression of g, and then we have it there. It's 3 cubed minus 2, 3 squared minus 11 times 3 plus 12. Okay, And if you do it carefully, you will arrive at a p-value of -12. Okay? Meaning that your coordinates for B is 3, -12. Okay, so obviously you can double check with your calculator if you want to do that. So we have obtained a full set of coordinates for point B. Remember, this B is on the tangent, this B is also a point on G. So now, are we ready to solve for T, the y-intercept of this tangent? Yes. So we can proceed to say, because this is our x coordinate, this is our y coordinate, our x will go there, and our y will be substituted for f of x. So -12 is equal to 4 times 3 plus t. This gives us 12 minus 12, therefore t is -24. Good. So we can come this side and fix the value of t, or replace t with what? -24. Well, we can still have it as plus t there, it's fine. So that is what we have. So we've made significant progress there. Now, are we ready to make our way to find our coordinates then? The coordinates for A, yes. What does A represent? Again, it's a point of intersection, and therefore this equation represents the values of x. When we find them, it will be those x coordinates at which those 2 points of intersection are. And we already have one, it's a 3. So we expect another one to be a different number, not a 3. So then we can simplify here. X cubed, the 4x and the -24 we transpose, take it to the left hand side, and then it should be -15x, okay, plus 36 equal to 0. Okay, so it's a cubic function, it's a cubic expression, and we need to factorize. What do we know? One of the factors is x minus 3. Okay, and we don't know, this is our linear factor, we don't know our what? Our quadratic factor. How can we get it? We can get it through synthetic division, we can get it through the bx method, where you determine the bx term in your quadratic factor. So in this case, let's go for what? Synthetic method. Just saying 3, just bring down the coefficients. So it's 1, the coefficient there for x cubed. Then we bring down -2, the coefficient for x squared, the coefficient for x, -15, and then the constant there is 36. Good. We bring down the 1, okay, and then we multiply. 3 times 1, it's 3. -2 plus 3, we get 1. You repeat the process. 3 times 1, it's 3. -15 plus 3 is -12. We repeat the process. 3 times -12 is what? 36. 36 minus 36, that gives you 0. So that means you are done, where your remainder is 0. X minus 3 fully divides into that polynomial or that cubic expression to give you the following. Now, how do you continue from here? Remember, these were the coefficients of your original expression or your original function, the cubic function. So this becomes the coefficients of your quadratic expression that you are looking for. So then this becomes x squared, that becomes plus x, and that becomes -12. And then we bring down this guy right here, x minus 3. What does this represent? G of x, where g of x is equal to 0. Can we further factorize this? Yes. X minus 3, x plus 4, and x minus 3 equal to 0. These two are the same, definitely, therefore the x-coordinate for A is negative 4 from here, and it makes sense to the sketch, right? The position of A is to the left of the origin, okay? So it does make sense that you must get a negative x-coordinate. Now, how can we get the corresponding y-coordinate? We know that it is a point on the tangent, it is a point on the cubic graph. So we can substitute, okay? If we substitute into this expression right here, okay, and you bring in the negative 4 there, 4 times negative 4, what do you get? Negative 16. And negative 16 minus 24 gives you negative 40. Okay, so your y-coordinate becomes negative 40. And therefore, the coordinates for A is negative 4, it's negative 40. Okay, does it speak to the sketch? Yes. A is also below the x-axis. So therefore, we expected that it will have a negative y-coordinate as well. Right. So this was not so much difficult, but it is complex in such a way that you had to connect different things and also remember this important relationship and that important relationship, and during that process solve for your unknowns that were there and know exactly which points to use for that purpose. I believe this was helpful, and for more videos, remember to click on this button there, or that overlay of the video, so that you can enjoy more videos under the playlist of mathematics. All right. Remember to subscribe as well if you have not done so, because then you'll help the channel to reach more people who can benefit from it as well. Okay. Thank you very much for tuning in. Go out there and excel. I wish you well. Thank you.